Now it's okay. Yeah. Hello, everyone. Today I will going to show you the work on the offload LDBC. This work has been done with Xilinx and VVDN, and also has been done with Professor Florian. The LDBC is considered as a high computational consumption component. So it's a good candidate to offload to FPGA, and in order to reduce CPU load. In this work, we are using the LDBC IP from Xilinx, and also the driver provided by VVDN. So we are going to show an end-to-end SA demo with LDBC offload for uplink transmission. So first, I will present a little bit the current status about uplink decoding. So today we are using the thread pool in OAI. The transport block is split into several code blocks. So each code block process use 3 decoding components, like the interleaving, rate dematching, and the LDBC decoding. So we can run for each decoding process on the different CPU core if we have enough core. Today with Xilinx T1, we can already run these 3 components in FPGA. So with the 3 component interleaving, rate matching, and the LDBC decoding. So if we have a look into the code, so the uplink decoding is done by the NR URL decoding. In this function, we are using several threads. So each thread is running for different code block. So as we can see here, we have, so I think it's not full screen. Yeah, okay. As mentioned before, so we have these 3 components running on the worker thread. So this work, we are going to replace this thread pool with a single thread. So a share library is created to implement the interface with TBDK. And also this share library can translate the OAI descriptor for the ULSH decoding into the required parameter for LDBC decoding. So it's like the code rate and also lifting size and all the parameters needed for the LDBC decoding. So this TBDK API is based on the on the top of TBDK, we are using the test BBDev. This IP, we are using only the mod 1. It means code block mod. So each time we can only decode 1 code block. So we are using a loop to run for the multiple count blocks. And the T1 is connected by the PCI Express to the server. So yes, and also the branch name for the IDBC is IDBC offload T1 MR. So the merge request is ongoing. It will be merged into developed very soon. So in this demo, we are using subscale spacing 30 kilohertz, 12 OIDM samples, and 2 DMRs in SISO mode. Bandwidth is 60 megahertz. For the TDD configuration, we are using 2 uplink slots. We can also use the 3 uplinks. No, I think there's still mistake. It's a 2 uplink slot and 7 downlink slot. So we can also use 3 uplink slots and 6 downlink slots. The UE is a commercial UE, Quectel 500 QGL. So we have done also some simulation for the T1. On the left side, you can see the performance is better, a little bit better, let's say, than the soft LDBC. So it's around 1 or 2 dB lower. So we still have some issue for the very low MCS and the highest MCS. Yeah, we still need to figure out the root cause. And also for the execution time on the right side, so we are using less time for T1, even we use only 1 thread, because all the channel decoding is running on FPGA. But for the soft LDBC, we need to run with multiple threads. So the thread pool we are mentioned before. Yes, so let's go. Okay. So in this presentation, so we will show a demo SA end-to-end connection. So all this 5G run is from OAI, and also the 5G core is from OAI. So all of them are running on the server. It's from AMD server. Except the channel decoding, LDBC decoding is uploaded to T1. And the 5G core, we are using only, I mean, a necessary component from 5G, OAI 5G core, but there are more components available. So if you need more information, maybe you can check on our website. And so the RU, we are using the USP N310. It's connected to the server with genome. And we have 2 Quectel UE connected to the genome over the air. So we are using the band 78. So yeah, this is our demo. So this demo is showed in mobile World Congress 2022. The AMD stand, so it's our partner AMD Xilinx. Let's share. Can you see the screen? Okay. So let's start it. So okay, this is the terminal for genome. So it started. Okay. So now we have this is one of the Quacktail UE. So we start the connection. Okay, so as you can see, the first one is connected. We have the IP address. And also on this UE, in fact, this UE is connected with a laptop. The UE, the Quacktail UE is like 5G dongle, so you connected by the USB. So yeah, the laptop is connected to the Quacktail by the USB cable. And also on this UE, we have this VLC server running on this laptop on the maybe you cannot see. Okay, it's running also on this UE as a VLC server. So you just start streaming one video, and now we can start second UE. Okay, so as you can see, it's also connected. So now, yeah. So now we can start for the VLC VLC and to change the IP address. So the 11 is from the first UE. So we can play the video is streaming from the first one. So this is the second UE. It's connected also with the USB cable to the Quacktail UE. So now, okay. Yeah. It's a start the video. So we have a second one for the. Yeah, I mean this is our demo. So this demo is showing the end-to-end 5G standalone connection with OAI genome and OAI core. So let me share it. The second one is just the video we are showing. Yeah. This is the video we have shown from one UE to another UE. Yeah. I mean, this is the video we are streaming from one UE to another. So I will stop the video here because it's just the content of the streaming video. Okay. So this is Where?
Now we can maybe have some time for question. On the chat, there's some question. There are some questions.
Okay. Okay, so the first question is, what are the required IP core for the to be loaded? Yes, this is the IP is provided by Xilinx and VVDN. So we are on discussion with Xilinx now to know if we can share the IP. Yeah, so now we are waiting for the answer from Xilinx. For this demo, no, the 250 megabit per second is not using the Xilinx card. It's another demo. It's only for downlink. In this demo, we are using Xilinx T1 for uplink. So it's not the same demo.
So sorry if I can just say a little word. For the 250 megabit per second throughput, this is entirely on, I mean, without any offloading, just an Intel processor and with, I believe, 80 megabits, 80 megahertz bandwidth or 60 megahertz. I'm not entirely sure, but without any offloading. So the Xilinx thing is something separate.
Okay, next question. So yeah, the transfer time from host to T1. So it's for one code block is around 10 or 12 microsecond. For uplink channel. In the uplink channel, the number of the variable mentioned. Maybe there's some mistake. I don't remember where I mentioned one. For the simulation. Okay.
I mean, if I can say a word here for this, I mean, the 106 PRBs corresponds to 40 megahertz bandwidth. I'm not entirely sure, but 60 megahertz bandwidth is another number, a higher number, I think 162 of PRBs. So I don't know what exactly this refers to, but you could make the same work with 60 megahertz bandwidth and not only 40. I mean, that's secondary.
Can I say something, Robert, here?
Yeah, of course.
This is the question I asked. So in one of the slides, the uplink channel simulation results where you showed the difference between soft LDBC and T1 LDBC. There in the description, it was mentioned that 106 PRBs with 12 OFDM symbols has been used. But for the demo, which has been right now showed, the 5G SA end-to-end system with commercial UE, there it was mentioned the 60 megahertz bandwidth will be used, has been used.
Yeah, I think this one of the slide is for the simulation. So I think it's for simulation. Maybe this one. Yeah. Muted. What? There's some echo. Oh, it's okay now. So yeah, so this one is only for uplink simulation. This is I mean, it's work both for 40 megahertz bandwidth and 60 megahertz bandwidth. But this simulation results is based on the 40 megahertz bandwidth. And the demo I have showed is working on 60 megahertz bandwidth. Okay. Another question was a road is an implementation, but okay, for the LDBC encoding, we have not yet done. Yeah, it's we can do it because for now we not need it necessarily because with the soft LDBC is already quite fast enough, but we can do it. Yeah. For the frontal process, I started working on the frontal 2 weeks ago, so it's still ongoing. Let me check. Next question. Do you have integration guide configuration on other? Yes. We have not yet done for the documentation, but it's quite similar to the SA test without offload. We have one parameter for the genome to enable the DBC offload. So, but anyway, I will add this into the documentation, and also the T1 DBC branch is the merge quest is ongoing, so I will add this documentation in this branch. It will be merged into develop. Another question, any detail you covered the installation of and OAI setup? Yes, I think this without offload, we have already tutorial for the end-to-end setup. When we change TDD configuration, do you change numbers? Yes, the TDD configuration is done in the config file. So when you run the genome, you have one config file. In this file, you can change number of the downlink slot and uplink slot, and also number of the samples. The number of samples, I don't know. For the mix slot, you mean? Or because I think it should be fixed for the 14 slot samples.
Yes, yes.
So-
I've been trying to change the TDD configuration actually. So as of now, it is for seven. For 7, it is 6 symbols, I think. That's how it's configured as of.
So if I may ask this, so I think you can just change this from 7.2 to 6.3, and if you
Okay.
leave the mixed slots in the middle untouched, then it should work. I mean, we don't test all of the different TDD configuration options, but I think this one should actually work. So if you just reduce the downlink slot by 1 to 6 and you increase the uplink slot by 1 to 3, then it should work. And you don't need to change anything for the mixed slots, so nothing with the symbols.
Okay, okay. So do the other numbers also, like, can we try 5 and 4 also, or only 6 and 3? Is there a fixed?
Well, these number of symbols that you have in the middle, this describes the mixed slot. So you can try to change this, but the chances that this actually will work is lower than, I mean, I don't know for what reason you want to change this, but if you just change the number of slots, then it's fine. And the mixed slot in the middle will just be one slot earlier, but otherwise unchanged. So that's what I would recommend to you.
Okay, okay. No, I want to change because we're getting a very low UL bandwidth. So yeah,
What do you get?
the UL, we're not getting proper MBPS for the UL. So we want to change the slot format a little bit. Will it impact? Will there be an impact if we change the slots?
I mean, change this configuration, maybe try. You cannot get proper uplink throughput because the MCS is limited to 9. And if you have more questions, then I would suggest maybe write an email to the mailing list and then we can continue discussing there, okay?
Okay, okay, thank you.
So go to next question. So can you please provide Xilinx IP core? Yeah, so this is as I mentioned before, so we are discussing now with Xilinx. When it's done, we will provide the IP core identification.
Is there an OAI plus SA plus phone tutorial? No. There's one phone that is known to work, which is the Huawei P40 Pro. And for this, you need some changes, which is actually one of the ongoing merge requests to support multiple PDU sessions. So if you could look into merge requests, then maybe take that merge request and then use the Huawei P40 Pro, and then it should work. And for the other phones, there's no, it's likely that it won't work. Let's say like this. And often the problem is that the phone does not even detect the cell because they are band locked or otherwise restricted, operator locked. So then you cannot have this. So then the next question, what are the parameters needed to be changed for 60 megahertz bandwidth? I put the file name for the 60 megahertz configuration file. So this has the 162 PRBs. So maybe look in there. Well, what is the maximum performance reached? The throughput? Well, the maximum throughput, as we have already discussed before, is the 250 megabits per second throughput in downlink that you can achieve. And minimum latency, there's one merge request open by Raymond, something with AW2S Jaguar in the name, which will soon be merged. And there, the minimum latency can be as low as 5 milliseconds. And if you look at our run roadmap, then towards the end of this year, maybe beginning of the next year, we will try to get down to hopefully 2 milliseconds.
Yeah, I just want to come back to the question for the multiple code blocks. Yeah, I think when I said there is a code block mode, but in fact we have this IP working on one code block mode, but we can run the loop to call it again. So we can working on multiple code block mode. So I mean, it's already done. So go to next question. In your previous setup, I came to see for the spectral analysis.
I mean, maybe I'm not sure what is meant with the spectrum analyzer, but maybe you mean the scope. So there is, I think, the parameter D, a small d, that you can pass to the NOSoft modem, and then this scope should pop up, and this exists for all of 4G and 5G eNodeB or gNodeB and also UE. So try the parameter D, and if this doesn't work for you, then maybe write a mail to the mailing list. Is there any explanation for soft modems? For the graphs, well, there is not that much documentation, sorry. So there are some more questions that are coming in. I saw something about how can I know which QQAM size the SA setup is using and how to change the QQAM size either from configuration file or code. So until now, it was restricted to this first MCS table, which is up to 64 QQAM. So the maximum there was the 64 QQAM. Since 2 weeks or 3, I believe there is code merged to enable 256 QQAM if the UE supports it. So basically the GNOD will always enable it if the phone supports it. And this is then done by default. So most of the devices that I know have this. So for example, the coaxial modules that we use here, they support this. So then it's always automatically enabled. However, this led to some problems with some devices. And currently I'm integrating one merge request where you can disable this. So there is a parameter. I can send this or put this into the chat in a moment. So, and then I think the next question is for you, Hongzi.
Yes. So yeah, from the IP Xilinx, so we can only use the code block mode. So I think the DBTK is I mean there are some function already done, but I think it's based on the Intel Altera IPGA. So for Xilinx, in fact, for now, it's not working for the multiple code block. But as I said before, we can recall it, and we can run multiple code block. there are no issue for this. Okay. Nice question. The phone. For the phone, I don't know. I don't use the phone for the connection, so.
So this is what I mentioned before. I mean, the question is my GNB doesn't find my phone. How to solve this problem? The issue typically is that the phone is band locked or operator locked. So basically, it probably doesn't scan actually on the carrier that you are operating your GNB. And basically, you have to unlock your phone. There's no general rule to do this. Maybe if you have a particular phone model, or I mean, or let's say differently, write an email to the mailing list with your phone model, and maybe somebody made it work already. And if not, then well, then I mean, we cannot help you in this case. So the next question to Hongzi, what is the performance gain in uplink using the LDPC offloading, and will the T1 card be mandatory to achieve higher throughput in uplink?
Okay, for this one, yes, for now, we are working on uplink, so we can achieve around 30 megabit per second. So it's I mean, it's not the limitation of the T1 because we have some other issues. Because for T1, we can achieve only for the channel decoding, LDBC decoding is can be go to as I remember it's of 8 gigabyte per second, so we can go higher. Yes, so I think to achieve the higher throughput is mandatory. Yeah, because if you use soft LDBC, then you need to run in parallel in the multiple cores. So it depends on your computer performance. But I think if you want to run, I don't know, like a massive MIMO, so it will be mandatory. So next question. Yes, it's a 30, yeah, 30 megabit per second. So, yeah, because we have some other issues for the uplink, but we will improve on the performance.